Hello, good morning. So this is Jose Gonzalez, Energy Conservation Manager at Stolt Tankers. Thank you very much for having me here today on the invitation, your kind invitation for this event. I'm sharing my screen, hopefully. Okay. Okay, so I guess you can see my the presentation I'm going to to deliver in this session today. If not, just please stop me and let me know. Well, as mentioned before, thank you very much for having me here today, for your kind invitation to this sustainability event in the Web Institute. My name is Jose Gonzalez, Energy Conservation Manager for Stolt Tankers, former seagoing engineer. I spent 5 years on board as a seagoing engineer up to second engineer in the rank, also naval architect by education, and 5 years ago I managed to read the viva of my PhD degree about biofouling. The session I'm presenting today is about one project we have, or one experience we have gained in our fleet in the shape of in-water hull cleaning technology from a manufacturer called Shipshave. The presentation today is divided in 3 main chapters. The first one is a little intro about Stolt-Nielsen, Stolt Tankers as a company, but well, it's a kind of naive exercise. Being the president of Web Institute, Mark Decini, he has spent almost 40 years in the company. So, well, anyway, I will make my best to explain a little bit what Stolt-Nielsen and Stolt Tankers is, but for sure Mark will have a much better and wider view on the company. Second chapter of or second part of the presentation today will be about biofouling, which is the topic we are trying to eradicate, or the issue we are trying to eradicate by means of this in-transit hull cleaning. And the third part of the presentation will be about the trial we have run for this in-transit hull cleaning concept. Stolt-Nielsen is a group of companies, is a world-leading liquid chemical product logistics provider, and there are 5 divisions part of the company. Stolt Tankers, that is the division I belong to. Stolthaven Terminals, Stolt Tank Containers, Stolt Sea Farm, and Stolt Gas, or some investment arm of the company. I will go briefly through Stolt Tankers in the next slide, so I will stop a little bit here, a little bit more here about the rest of the divisions. As you can see there in the screen, there are some key facts of or key highlights of every division of the company, some of them quite remarkable, as for instance, in the case of tank containers, the company has circa 44,000 tank containers in the fleet, which is a pretty respectable amount of tank containers. We own, fully own 10 terminals. We got JVs with other companies in 4 additional terminals. Our business, Stolt, our sea farm business is also quite remarkable, producing 5,700 tons per year of turbot. So yeah, all in all, this slide is aiming to provide a whole or holistic helicopter overview of what the Stolt-Nielsen Group is at a glance. We are around, we are 6,600 employees worldwide. In my case, I'm based in Rotterdam, in the Netherlands, and this is leading us to the next slide because I'm part of Stolt Tankers division of Stolt-Nielsen Group. The Stolt Tankers division of Stolt-Nielsen Group owns a total of 164 ships. We got 164 ships in our fleet. We got directly under our management 104 of them. The rest of the ships are part of other pools and chartered by others. The total DWT, the deadweight tonnage of the whole fleet is 3 million. And obviously, the Stolt Tankers has got sustainability agenda in place and reduction of our carbon intensity, which is aiming to be 50% relative to 2008 by 2030 and 100% carbon neutral by 2050. The reason why I have included these pictures of ships of some of our chemical tankers in the slide is because in the fleet we got 19 different technical classes of ships, depending on the place where they were built and the tonnage. So we got some ships like this one, the one I'm marking in the slide, that is a C26. It's a ship built in China, 26,000 tonner. We got C38s. We got J12s built in Japan. We got M43s, ship built in Norway, 43,000 DWT, which is pretty respectable tonnage for a chemical parcel tanker. We got D37s built in Denmark, 37,000 DWT, and so on and so on. From the technical point of view, from the technical aspect, it is challenging because, well, the chemical parcel tanker itself is a challenging piece of equipment. It's a kind of breed apart in the shipping industry. It's completely different to other kind of ships. And obviously, in our case, we got also a plethora of different propulsion packages. They are conventional 4-stroke, conventional 2-stroke, diesel electrics, etc. In terms of routes and trades, our main hubs are ARA, Amsterdam, Rotterdam, Antwerp, Houston, of course, Singapore, but we are also trading to many other areas in the world, Far East, Japan, Africa, South America, etc. It is important to highlight this aspect because regarding the topic I'm going to present later in the slides, biofouling is happening in all these areas, obviously, and some of them is happening in a more prominent manner than in others. But for us as a ship owner, having the fleet trading around worldwide, not just only focus in a given area, makes the fouling especially challenging, the fouling topic especially challenging. The next slide is presenting a high-level view of our decarbonization ambition. sustainability aspect has gained a lot of momentum in the last 2 years, a year and a half. And well, in our case, we got a short-term agenda, very focused on the optimization of operational behavior, optimization of technical systems. We got already on board and some upgrades up to 2030. And then the challenging and the challenges and the commitment till 2050 is going farther than this kind of optimization, and is taking us to go to different partnerships to find the sustainable supply chain for carbon neutral fuel, and also to be clever in the way we are renewing the fleet with our view in the ship of the future in order to fulfill the ambition we got for 2050. Specifically talking about the Stolt Tankers Energy Conservation team, which is the team I'm leading, is part of a fleet support department in the ship owning division of Stolt Tankers. Our main goal is to optimize the energy usage on board and reduce the energy waste of the fleet. We have to burn, obviously, fuel to move our ships, to move our cargos, to satisfy our customers. But of course, there are some strategies we can utilize in order to reduce the energy waste we are producing in the fleet. We are a total of 5 members in the team. And I wanted also to honor Web Institute in this slide, because we have consistently had interns from Web Institute during the last 4 years. You see in the screen Matt Migliosi, Dwayne Lee, Kevin O'Keefe. They've been in 2019, 2020, 2021, 2022. In the case of Kevin, he has done a couple of interns for Stolt. And now in 2023, we got 2 additional colleagues of you joining as interns Stolt in the shape of Darren Cook and Richard Hill. So there is a close collaboration with Web, and we are obviously very happy to have Web interns joining Energy Conservation Department, and it's people that has provided a lot of value to the activities of energy conservation and obviously Stolt Tankers. Closing this first part of the presentation about Stolt-Nielsen, Stolt Tankers, for us in Energy Conservation Department, in order to fulfill this greenhouse gases ambition, this reduction in energy waste, the reduction, obviously the consequent reduction in the fuel bill and emissions of the fleet. In terms of the activities and projects we are working and we are focused on, diversity is key. Maybe for some of you, this sketch is familiar. This is a sketch has been blurred on purpose, but it's taken from the DNV forecast, greenhouse gases emissions forecast. I'm sure it's familiar with you. This is the ramp. If we do nothing, this is the reduction we have to do. And the reason why I'm including this sketch is because I think it's a very good way to reflect that for us, diversity to reach these greenhouse ambitions and this energy waste reduction, it is key for us to keep a diversity mindset in terms of the projects we are doing. We are very focused in different areas. I'm presenting in the slides some of them. We are very focused in coatings, not only for hull, also for propeller. We are also very focused on some energy-saving devices, like the typical advanced type of propeller boss cap fin, Mewis duct. We are also very focused on the measuring devices in the shape of kilowatt-hour meters, torque meters, etc. The RPM pitch optimization of the ships, green fuels. Some trials have been done a year and a half ago in the shape of biofuel. There is some information available in our website. Collaboration with other people, in this case with the Myers McLean Moller Zero Carbon Shipping Center, collaboration also with universities, etc. Some modification in the main engines. And last but not least, one of the most important parts, which is the proper communication, involvement, and inclusion in all the projects of our crews. The colleagues we got on board, the people that is operating the ships, and the people that is key to make possible all these activities going on a proper fashion and successful manner. Okay, hopefully this has given a kind of a nice overview of what Stolt-Nielsen, Stolt Tankers energy conservation is. And now I'm heading into the topic we are dealing today. What is the issue we are trying to eradicate, or what is the problem we are trying to solve by means of the in-transit hull cleaning? And this is the biofouling. Biofouling is gaining a lot of momentum in the agenda, in everybody's agenda, not only ship owners or ship operators, regulators, companies, etc., etc. So it's mostly and it's already been identified as a major contributor of fuel consumption increase, and is being identified as we speak as one of the major contributors for the CII ratio or rate decrease on a given ship. But it's not new. It's an old ceremony. It's something, as far as we've been putting ships floating in the sea, in the water, we've been experiencing in the maritime industry biofouling. You can see on the left-hand side the carrying at Torres Strait of a couple of French corvettes in the 18th century. And on the right-hand side, you can see one of Stolt Tankers, chemical parcel tanker in a floating yard in Singapore a year ago. So this is not new. It's something we've been doing for a while, but for one reason or the other, so far we have not been, or the industry as a whole has not been successful in fighting, mitigating, and reducing the impact of biofouling. The principles of biofouling. A couple of interesting definitions. The definition provided by IMO in 2011, accumulation of aquatic organisms as a microorganisms, plants and animals on surfaces and structures immersed or exposed to the aquatic environment. And another one, in my humble opinion, is even more interesting, coming from Charaklis. Charaklis is that person you can see on the picture. He was a researcher of the Center for Biofilm Engineering, Biofilm Engineering in Montana University in the US. And Charaklis already in 1990 defined biofouling as the undesirable accumulation of a biotic deposit on a surface. Very interesting researcher. Unfortunately, he passed away late 90s when he was at a young age because of cancer. But he was one of the people putting foundation stone on this topic. Two main types, of fouling: microfouling and macrofouling. The reason why I'm highlighting these two types is because we will see, and you will see later during the presentation, the importance of microfouling. Microfouling is that fouling due to microorganisms that creates biofilms, and macrofouling is what is coming on a later stage in the shape of mussels, barnacles, oysters, etc., etc. How long does it take? The results, or the slide, this slide is presenting the results of the research for my PhD. It was about efficiency on, or the impact of efficiency of on heat exchangers due to microfouling. It's not necessarily about the propellers or hull of the ships, but in the end, it's about microfouling, and it was related to heat exchangers refrigerated by seawater, which is heat exchangers, condensers used on LNG gas tankers. Okay, the main message in this slide is presenting that the growth of the microfouling is happening on something that is called sigmoidal curve. There is at the very beginning an induction or colonization phase where all the bacterial is attached to the surface. In this case, it took around 8 to 10 days-ish. Then there is an exponential growth. Once the foundation is there, the growth happens very, very quickly. And it's something can take, on average, 20, 30 days, 35 days. It really depends on the seawater temperature, salinity, the conditions in the environment around the microfouling creation. And then we are reaching the third stage, that is what is called plateau or quasi-steady state, when the fouling is getting, the microfouling is getting a kind of a steady condition, ready to allocate the macrofouling. In the specific case of this research, it took circa 45 days to create or to have a biofilm in the internal surface of the tubes of the heat exchanger. So it's giving a very good indication how fast it grows. The ambient conditions for the research, it was average seawater temperature of 15 degrees in the period of time ranging from May to September, and the location of where the research took place, it was in the Atlantic Sea. Being more specific, is the northern part of Spain, a place called Santander, that is the North Atlantic coast. The reason why I'm including this part is because people, or some people, tend to think fouling is only related to tropical areas, equator areas, very high seawater temperature areas, and it's not necessarily the case. What is the impact? I just, more than Jose explaining here a lot about the impact, I thought maybe it was better to include some of the key references from the bibliography. One of the most remarkable ones, and one of the, in my opinion, more interesting ones is the impact evaluation coming from Mike Schultz. Mike Schultz is working for the US Navy. based in the U.S. Navy research facility in West Virginia, and he's been vastly evaluating the impact of fouling in Navy ships. You see there that you can see there that increase in the of 70% can or will create an increase in power estimated to be between 1.5 to 10%, depending on the biofilm thickness and percentage coverage. There are others, like other references like Demirel and Couch and Dawson, that are also including, in the case of Demirel, much more specific, focusing much more in the container ships. And they are providing very interesting insights and figures related to fouling impact. Also very interesting, not only about propellers and hull, it's also about niche areas, seawater circuits, etc. So again, industry colleagues, stakeholders tend to think everything is about propeller and hull, but there is much more impact linked to biofouling. And this is linking very nice with the next slide that is talking about the myth busters. There are a number of myths in the industry. For me, applying or having had the opportunity in the past to work in fouling or biofouling in power generation facilities, nuclear and combined heat and power facilities, it's very evident that there are still some myths in the marine industry we have to get rid of. I have listed there some of them. Impact is not so high. Cold water temperature does not favor or create fouling. The cheaper the better. Fouling is only related to our container ship fellow colleagues, that they are full blast the whole time, etc. But the reality is that in the end, we are finding what you can see in the pictures on the right-hand side of the slide. So this is also, there is also a pretty heavy awareness exercise we have to do in the marine industry in order to create momentum and also to help our colleagues and other stakeholders to identify the impact of biofouling is quite significant if we don't take appropriate action. What is one of the actions we have taken in Stolt Tankers in order to try to mitigate the impact or to bumper the impact of biofouling in the ships we are managing? One of the strategies, not the only one, is one of them is in-transit hull cleaning. In-transit hull cleaning is about the sigmoidal carb. This is again a piece of information I shared before, and this is one of the sources coming from Fleming that is presenting how the sigmoidal curve is happening again. So again, you can see the induction or colonization phase, the exponential growth, and the plateau. And this is exactly what happened there. The difference is that in this research, we were dosing a chemical compound aiming to eliminate the microfouling, and then the plateau, it went down. But everything in the in-transit hull cleaning is about this curve, which is again microfouling. When we got the microfouling created, we got already the basement and the foundation for the macrofouling, for the barnacles, oysters, by means of different biological mechanisms, extrapolymer substances. They create extrapolymer substances that favor the attachment of all these biota there. And there are also some other fascinating phenomena like the van der Waals forces that are helping to create the macrofouling, which is our challenge, our issue in this aspect. So the working principle of in-transit hull cleaning consists of a semi-autonomous robot that is tethered to a winch in the forecastle deck, attached, as you will see later on in the pictures, to one of the maneuvery equipment there. And then the robot consists of a lance with some soft brushes. It has a camera, kind of spoiler, and at the other end, there is a towing line where the rope is coming from the winch. You will see later on in the pictures the real thing, much better than this designer's recreation. And then it's just wiping out the sides of the hull. The soft brushes clean the hull underwater using a defined pattern that is the in-transit hull cleaning robot, and this is the reason why they call it robot, has got a software that you, let's say, calibrate with the dimensions of your ship, of the vertical size, how far you want to clean down in the vertical side. In our case, majority of cases, down to the keel bilge, and then how far you want to go up, which in our case is around 80, 70 centimeters to the seawater surface. So you are, let's say, teaching the device what, how, and what is the cleaning area it should do. The ship. We ran a trial on board one of our ships. She is called Stolt Shipshave. It's a chemical parcel tanker that belongs to our Asian fleet. Stolt Tankers has the fleet divided in four different fleets: Asian, Americas, European, and inter-European fleets. Stolt Shipshave belongs to the Asian fleet. She was built in 2004 in Japan. She's powered by a two-stroke engine, able to deliver circa 8,000 kilowatts at 120 RPM, and she's equipped with 3 generators. And you see they are the main characteristics: 170 meters long, breadth of 25 meters. She's what we call in Stolt Tankers J30, the ship built in Japan, 30,000 tonner. This is the ship where we ran the trial. She left dry dock on the 10th of May, 2022, and we ran the trial on board on the 18th of August, 2022. This slide and the next slide are presenting some pictures aiming to give a proper flavor what the trial was. So she was sailing mid-August from Port Said, Egypt, to Algeciras, Spain. Pretty nice weather conditions. It's something that we have to take into account because the conditions for that trial were pretty ideal in terms of Beaufort, etc. The trial, it was presented to the crew on board, and this is the officers' mess room where we presented the trial to the crew, and obviously it was a familiarization with the crew was carried on board in order to properly run the trial according manufacturer, let's say, guidelines, in order to try to see if the equipment is a successful piece of equipment or something we could use or is not giving value to us. As mentioned before, this is the air winch with the rope attached to the winch. The rope is linked there to the lance, and the winch is connected to one of the mooring equipment in the forecastle of the ship. So we decided for the trial there is an option for an air winch or an electric winch, but we went for the trial for the air winch in order to minimize as much as possible the risk due to explosive atmospheres, etc. So in this detail of this picture, you can see the detail of the brushes. They are pretty soft because the principle is to remove micro-fouling. This is not a device to remove macro-fouling. Even this is not the device to remove light to moderate fouling. It's a device that needs to be used, or the purpose of this device is to be used on the very early stages of fouling. So, yeah, the result of the trial on board was successful. It took around 2.5 to 3 hours per vertical side. So it's circa 1 working day for a couple of crew members to clean the sides, the vertical sides, let's say the area of the vertical sides in between perpendiculars, because obviously the device cannot, or it's not recommendable to get into the third side. It's not able to clean the bulb, etc. So the cleaning side, the cleaning area we are considering is always in the vicinity or in between perpendiculars. So for a ship like Acer, that if you remember from the previous slide, she's 170 meters long. It took around 1 working day to clean both sides. We know there are other owners that have chosen the strategy or the trial, or the strategy for the trial, cleaning one of the sides and leaving the other side, for instance, port side of the ship, leaving a starboard side without cleaning. This is aiming to compare what is the impact and also to learn how fouling grows. It's not our case. We are aiming to go for both vertical sides of the ship. Identified value. There are 4 very interesting aspects there. Obviously, the reduction of fouling in the hull of the ship, on the vertical sides of the hull of the ship. To keep regular maintenance, or to adopt more a kind of proactive cleaning rather than reactive when we put a diver in the water and we see by means of the diver there is fouling and then we react to that. The philosophy here is to do more a kind of a proactive approach. A very important one, maybe should be at the very top of this list, is about the CII rate maintenance. Fouling is a great contributor, negative contributor to the CII rate, and we see proper fouling strategies will help us to keep the CII rate of a given ship in the good area of the rate, I mean A, B, C. And obviously also the reduction of unscheduled hull cleaning, which creates a lot of stress to the operation of the ship, to the different stakeholders in the company, even sometimes creating of hire, etc. So this is also something helping us as a company to properly fence this negative impact of fouling in our operational profile. The measurements were done by means of a torque meter on board the ship, and we also have been, this ship was equipped with the torque and thrust meter already a year and a half ago. And we have also developed a dashboard by means of that present the thrust measure. And we think, we have seen that there is an impact between 1.5% reduction, fuel consumption reduction during the trial. Hopefully the video will work. Okay, hopefully you can see at your end in the university, in the institute, the video. This is a recording from the trial on board Stolt Acer. So you see how the device is working. It's now going down to the vicinity of the built keel, and then going up. So the rationale behind is to shave, to clean the surface, the slides, the microfouling in the surface, going up and down. The last slide, hopefully I have managed to keep your attention during the whole presentation. This is the very last slide. And it's obviously about something that is very, very important, which is the regulatory framework. Obviously, as you all know, we got a pretty strict regulatory framework in the marine industry, in the shipping industry, for all the activities we are doing, environmental activities, and MEPC, Marine Environmental Protection Committee of IMO, is one of the committees, together with Marine Safety Committee. There's the only two committees in IMO. The rest are subcommittees hanging from these committees. And of course, biofouling is another aspect that is already regulated. General perception is that the regulation is pretty soft. And as soon as some new technologies, some new strategies are coming to the forefront side of the topic of the industry, the regulatory aspect is also arising. In this case, the regulatory aspect is what is related to the with or without capture of the cleaning of the debris you create by means of cleaning. There are already some discussions going on in different forums. The corresponding group of IMO will issue a report to the protection subcommittee of IMO next year, aiming to feed the MEPC specifically about this aspect. So MEPC next year in April, I think, is running. There is one now happening end of November. There will be another one running in April next year. There will be already some insights and proposals from different countries and entities to the committee. Removing a slide in the middle of the ocean should not cause any kind of damage or pollution. Different discussion is what would be the case in the economic zones of every country, in the areas every country has got jurisdiction on. But what we know at this moment in time is that the two countries that are at the forefront of regulations in biofouling aspect, I mean Australia and New Zealand. In the case of Australia, they allow cleaning outside the 12 nautical miles zone. So, okay, this is not, I'm not saying here that IMO will follow that case, but they tend to learn from countries or entities have got certain level of experience and understanding of the topic. These two countries have got a lot of understanding, a lot of local regulations about biofouling, pretty clear, pretty concise. So it's envisaged that the IMO will counsel and will consult how these regulations are working, what is the impact, etc. So, yeah, hopefully the presentation has been interesting, and yeah, I'm more than happy to answer any question you may have. Thank you.
That was great. Are there any questions? Yes.
This device seems to only clean the sides of the ship. How does biofouling resistant implications compare between the bottom and the sides?
So I listened something, but very, very far in the distance. If someone could please repeat the question or.
Yeah, of course. The question was that this method cleans the sides of the ships. How does biofouling affect the bottom shell plating in addition to the sides?
Okay. Based on my experience, when there is fouling when you find fouling in the flat bottom of the ship, majority of the cases is due to a coating failure. It's not an area that is prone to have major fouling events. We have found some cases, even at the level of calcareous, that is pretty severe, but it's always due to coating failure. Our ships are sailing typically 10, 13 knots, and it's not the kind of case we are finding frequently. What we are finding quite frequently is the fouling in the vertical sides, and this is something creating an issue. I would also emphasize importance on other areas like niche areas. There is not a lot of attention at this moment in time, but it's another critical area. Not only because of regulations, also because of some technical issues in the cooling water circuits. And obviously, propeller, of course, that's obvious.
Yes.
Is this cleaning methodology just specific to tankers, or are we trying to other types of ships to use this particular cleaning?
I think I managed to listen that one. That correct me if I'm wrong. The question was if this specific cleaning strategy is only for tankers or other ship types could be, or the cleaning could be done on other ship types. If
Yes.
that's the question, the in-transit hull cleaning applies to any kind of ship. In fact, majority of when we were asking the technology supplier, they were referring themselves to some experiences on board bulkers and product tankers. But the technology applies to all kinds of ships, also container ships, even sailing up to 20 knots, and small ships. But there is a limitation in terms of length. If my memory serves me right, is 70 meters long. But it applies to all kinds of ships.
Thank you.
Tony?
This technology be used in lieu of utilizing anti-foul tanks, copper-based biocides?
Apologies, I didn't get this one. If someone could please.
The question was, can this technology be used instead of anti-fouling coatings?
That's a question we are already discussing within Stolt and in other forums. At this moment in time, 8th of November 2022, the answer would be no. We still need to apply kind of medium high quality coatings. At this moment in time, it's not a kind of silver bullet that could solve the coating issues. So the way it's perceived by everybody, not only in our experience, other owners, we have had discussions with them, the manufacturer or the supplier itself, and some people from academia specialized on fouling topic, is that the key is the proactive approach. The key is about microfouling, but making long story short, it would be kind of all hands on deck, all kind of approaches and combining approaches for fouling mitigation should be applied at this moment in time. Hopefully, in maybe 5 or 10 years' time, the technology will develop in a way that we can say this kind of technology or other technology can solve the issue by itself. But at this moment in time, it's a combination of that.
Becky?
I have 2 questions. The first is the most obvious question. After the successful trial in August, what's the plans for continuing on that test ship and on other ships of Stolt? And then my second question goes back to where you reported the results of 1 to 1.5% improvement in your fuel consumption reduction. Do you have data that did that bring it back to the point where it came out of the yard, or yeah, how close did it bring it back to its original condition? I guess is my question. The original condition when it came out of the yard.
Very good questions. Very nice questions. Thank you for that. The very first one, if I understood correctly, is about the plan after the success of the trial. We ran the trial in August, and then we presented the case to the leadership team in Stolt Tankers mid-September. And now we are applying the same principle in another 5 ships. So at this moment in time, we are applying the same principle in a total of 6 ships. So there is a continuation within Stolt. There is a continuation of this strategy. This is let's say it's not just only to do a trial for the sake of trialing things. It's also the wider application of a strategy or technology like this in our way or in our path to reduce fuel bill and reduce emissions and greenhouse gases emissions. Second question, very interesting one. Yeah, you are very right. Ship was in dry dock. She left dry dock early May. So there is a plethora of ships of things have happened there, as everybody knows. Fresh coating, some main engine not modification, but overhaul in the fuel pumps, etc. So when the ship is leaving dry dock, is living in a pretty nice condition. That was the very first thing we were discussing before running the trial. How could we elucidate what was exactly the impact of this microfouling cleaning in the vertical sides and avoiding mask or to avoid masking other aspects like the fresh coating on board. This is exactly the reason why when we ran the trial, we kept a close eye to the torque and thrust. The ship is equipped with the torque and thrust meter. So we know the torque the engine is delivering and the thrust. By means of that, we know exactly where the engine is in the SFOC curve, and we know also the propeller efficiency coefficient by means of the thrust. And that's why we are quite confident that window from 1 to 1.5% impact is something pretty close to reality. Why not more accurate, you may ask? The trial consisted in 3 cleanings. The very first one was just for the sake of testing the equipment. So there is an option to use the device without brushes, exactly for that purpose, for the people to get familiar with that. That was the first go. And the second and the third were already running with brushes, with 3 days difference. The one we have a stick to for in terms of results is the one on the third day, the third trial, the last one when the ship was approaching Algeciras. So yeah, we think that's the reason why we think it's quite accurate. And of course, right now we are also very focused as a part of the continuation. Of course, we are very focused in the continuation of the cleaning. The ship is now heading to Japan. She's doing the Trans-Pacific crossing. She completed another cleaning on the 27th of October. week and a half ago. And we will do another one early 2023. So hopefully I have answered your question.